Hello everybody, this is for the Quiz 4 review and mid-semester review for AWC's General Chemistry 1. And right now we're going to cover chemical reactions. So the first question is, give the chemical name for each product formed when mixing an aqueous solution of copper bromide with an aqueous solution of iron 3 nitrate. Okay, so this is a double displacement reaction. So we're first going to see that we have CuBr2 plus FeNO3. So when we react this, I like to show it this way. We have A, B, C, D. And on the other hand, this is our cation and this is our cation. These are our two anions. So we're not going to just double displace any which way. Our cation needs now to go with our anion, and our cation needs to go with this anion. So this is going to look like CuNO3 plus FeBr2. Now I'm going to use a periodic table to answer the rest of these questions. So while you got out your periodic table, just think about this question a little bit and about what needs to go. Let's look at our periodic table. The two elements that we really want to pay attention to are copper and iron because they're transition metals, and so we're not entirely sure what their charge is until we see the rest of the picture, or that is what the molecule actually looks like. So if we see this, we can say then that from this charge, from here, we know that copper has a +2 charge because bromine normally has -1. So because of that, we need a +2 to sort of balance out this. Over here, iron normally has, we don't know what charge it has, but we know nitrate normally has a -1 charge. So because we have 3 of these, this must mean that this is a +3 charge. So when we write it out over here, this would be copper nitrate 2, and this would be actually, let me get rid of this, I'm sorry. This would be FeBr3. You can't really see that, so I'm just going to cross this one out and rewrite it. So it would be FeBr3. And so when we name them, this is going to be copper 2 nitrate, and this is going to be iron 3 bromide. Okay. Now let's finish up these chemical reaction questions. An aqueous solution of potassium chromate reacts with an aqueous solution of lead 2 chloride in a double displacement type of reaction. What is the equation? So we'll say Pb, and chlorine normally has a -1 charge, then we have Cl2 plus potassium chromate. So chromate is Cr, so let's just write this one over here. Okay, so let's answer this question. Aqueous solution of potassium chromate reacts with an aqueous solution of lead 2 chloride in a double displacement type of reaction. What is the equation? So we have K plus CrO4 minus 2, so then this is potassium chromate. And we also have lead 2 chloride, so that's PbCl2. Now let's react these. Kind of the same way we did up here. We're going to say this is A, this is B, this is C, this is D. Our two cations, our two anions. So we have Pb, CrO4. Now we can leave it like this because lead has a +2 charge and chromate has a -2 charge. Plus KCl. Okay, plus charge, +1 charge here, -1 charge here. Now this isn't balanced. To balance it, we could start by putting a 2 right here. And so now we have 2 potassiums, 2 chlorides, 1 lead, 1 chromate, and we're balanced. Now let's look at this equation. Zinc plus lead 2 chloride turned into lead plus zinc 2 chloride. So what type of reaction is this? It's a single displacement. We're not changing all of them, we're just changing one. So A plus BC becomes B plus AC. Okay. What is oxidized? What is reduced? What is the oxidizing agent? And what is the reducing agent? Let's look at this equation. Elemental zinc plus lead 2 chloride turns into elemental lead plus zinc 2 chloride. This is a single displacement reaction because we're only changing one of them. What is oxidized, what is reduced, what is the reducing agent, and what is the oxidizing agent? Well, zinc, because it's elemental zinc, has a 0 charge. And here we see that lead has a +2 charge and chlorine has a -1 charge. It's because for it to be 2, and chlorine normally has a -1 charge, this must have a +2. Moving on to the product side, so these were the reactants, these are the products. Elemental lead has a 0 charge. Following that same line of thought we did for this one, zinc has a +2 charge, and chlorine still has that -1 charge. Now, because nothing happened to chlorine on either side, we don't need to worry about it being oxidized or reduced. It's just there to complete the equation. But instead, let's look at what is oxidized. Well, what is oxidation? Oxidation, if we follow the oil rig, we say oxidizing is losing. What is it losing? Electrons. Reduction is gaining. It's gaining electrons. So let's put that. Oxidation, losing electrons. Reduction, gaining electrons. Okay? So if it's gaining electrons, it becomes more negative. If it's losing electrons, it becomes more positive or less negative. So let's look at lead. Lead went from a +2 charge to a 0. That means it's become more negative. 0 isn't a negative number, but it's more negative than +2. So I would say then that lead was being reduced. Pb +2. And now let's look at zinc. Zinc went from a 0 to a +2 charge. While 0 isn't negative, +2 is very much more positive than zinc 0. So we can say zinc was oxidized. So that's zinc, elemental zinc was oxidized. That's a 0, sorry. So then what is the oxidizing agent and what is the reducing agent? Very often in these types of equations, they'll simply be the opposite. If this is reduced, if this is gaining electrons, it must also be the oxidizing agent, which is taking the electrons. If zinc is being oxidized, so it's losing electrons, it's also the reducing agent because it's giving away electrons. So this is zinc, this is again elemental zinc, and the oxidizing agent is Pb +2, which is also divalent lead. So this is the end of the chemical reactions video.